Today we have a special talk from Advanced Super Logic Sedan Berhad, presented by Mr. Aljay, and it is about robotics. Over to you, Mr. Aljay.
Yeah, thank you, Fahim. Thank you for having me today. So today, my name is LJ, and I'm from Advanced Logic, and today I'll share about the topics of should kids learn robotics from young. So today's topic, I'm going to cover 7 things. The first thing is introductions. Then after that, we'll talk about what is robotics because a lot of people don't know what is robotics. And the third thing is what's the levels between the robotic skills? How do you judge the level of your kids now? So the fourth thing is how can your kids start learning robotics if they have zero basic? Okay. The fifth one I will share about our microbit robotics program, and then I'll share you about our case studies. Then I will open up quick Q&A sessions for you. If you have any questions, you can ask me. So first thing, let me introduce myself. I'm one of the co-founders of Advanced Robotics at Berhad, and I have 5 years of experience in teaching robotics and programming, and even in industrial programming. And I was nominated for Leadership Excellence Awards in 2021. And I've conducted training for robotics and programming in the University of Nottingham, Malaysia, and also in different international schools. And I'm also one of the HRD Corp certified trainer. And what skill do I have is I know how to do PLC programming, specifically for Omron, and Python programming, C++ programming, JavaScript, Scratch, Lego EV3, and Microbit. Yeah, a bit introduction is about our company. Our company is called Advanced Super Logic Sedan Berhad, which is founded in 2020 under collaboration between Mecca Automations and Advanced Sedan Berhad. So our vision is to embrace innovative culture, continuous learning, and self-improvement to keep up with the technological trend. So these are the milestones. So when Mecca Automations founded in 2002, we do automating automations and improve manufacturing processes. Then Advanced was set up in 2018. We do advanced e-learning platform to promote active learning for teenagers. Then we collaborate to build up advanced logic and empower the youth in technological skills. Then we do close collaboration with different enrichment centers to hold boot camps and bundle programs in school. Now we are actively providing robotics and STEM workshops in international school and also university. So first thing, often a lot of people asking me, what is robotics? They don't understand what is robotics. Maybe in KL area, Selangor, Johor, and Penang, they know what is robotics because the area quite common. But in those very not urban area, they will ask you about these questions. What is robotics? Is it all robot considered robotics? So before answering these robotics questions, so what is happening right now actually? When you see the slide, right, a lot of things happening here is not in the movie anymore. It's in the real world. Maybe the AR now is still in a trend. AR and XR is still in a trend, but they are now in developing stage. As you can see that Apple also developed their new XR. XR means extended reality, which is mixed reality, with the Vision Pro, which costs around 15,000 ringgit Malaysia. So this one is no more a trend. It's happening right now. So now look at robotics. So what is robotics? It's based on the definitions online. Robotics is a branch of engineering that involves in conceptions, design, manufacturing, and operations of robots. The objective of the robotics field is to create intelligent machines that can assist humans in a variety of ways. So let's do it in a layman term. In the robots, we have 4 main components inside. The first one is the controller, the processor, which is called a brain of the robot. So that one is process the data and then transmit to the electronic components and mechanical structures to make it move. So the second one is program algorithm. Program algorithm is like a thinking of a human, but the program algorithm is a thinking of the robots, which is set up by the programmer. And the third part is the electrical and electronics components, those sensor, servo motors, those taking the data as input from the environment and trigger it to output for the servo to move the robots. And we do have mechanical structures. It's like our body and how we move. Okay? We have gears, we have frame, we have a lot of connections joined, and one is all about mechanical structure. So the first thing is the mechanical structure. So without mechanical structures, we can only call it a software, a software robots, or like what is that called, ChatGPT. So that one is without mechanical structures. So mechanical structure includes designing, prototyping, and assembly of the robots. So these are the frames and the body of the robot to perform movement and specific actions. So for example, in your machines, a lot of process you need to make, like bending the things or pick up the things. That one is the starting of the mechanical structures of the robot. Then we'll have electronic components. Electronic components includes those sensors, servo motor, wires, and cables that attach with the mechanical structures. These are these are the things to get input from the environment and then skip the output to the servo to make the robot move. Then we'll have a controller. This controller or core processor serves like a brain of a robot. Our programs will be downloaded into the controller to process data from input collected from the environment and give signal to the outputs like motors to move the robot. So you can see on the left, we have the first one is our Arduino. Arduino also we have different classifications. If you want more inputs and outputs, you can buy Mega. And the second one is microbit. So this is started very educational controller for those zero basic one. They can start coding even if they have limited budget. And the third one is EV3. EV3 is developed by Lego with MIT. They build Lego robot because a lot of people, they don't know how to make the frame. So Lego make it into different bricks. So if you want to make your own robot, you can build it with the bricks. And this one is the main brain. It's a controller which will give functions and program the and process the program. And the fourth one is the industrial version of controller, which is called PLC. PLC means that it's programmable logic controller, which is being used in industrial. And of course, this one is the old versions, and we do have new versions that can connect to Ethernet cable to do Wi-Fi connections to do IoT program. So this is Omron PLC. Yep, and programming algorithm. This is also very core part of a robot because without programming algorithm, you can make machine. So can only complete a specific task, only one task. So for example, you already know this line is going to do chopping, then send to the machines, then do packing. Then this one line is only programmed by machine, and this one is we call hard programming or hard wiring that only serve one task and you cannot manipulate it. So in robots, the program, we can call it algorithm. Algorithm is just the calculation method or the formula written inside, which is written by the programmer to enable robot to perceive its environment, make plans and decisions, and execute tasks. And the process of writing the program is called programming, or we can call it coding. And not just about the four main components. The four main components, you can see that it's a hardware and commands, which is the hard part and the soft part. So added up together, you can make a robot. But other than that, other than the knowledge of the hardware and the software, we also need logical thinking skills because to solve different tasks, we might need to have different algorithms. So that one is shape our logical thinking skill, and also problem solving skills. How do we solve problems with the robots? And not just plug and play. Okay, we want to do problem solving. So we want to make sure that our robots can serve the tasks more accurately, and also more precisely, and also more efficient. And also troubleshooting skill, because in robots you will face more problems, or you will face more challenges because robots consist of a lot of parts. So sometimes it's not the hardware issue, sometimes it's a software issue, sometimes it's not a software issue, it's not a hardware issue, it's a logic issue, sometimes it's a hardware issue, sometimes it's a sensor issue. So you need to know how to troubleshoot. And so that's where you come from. That's where robotics comes to an important part. So the fourth one is creativity and innovative thinking, especially when you want to build robots to improve productivity, to make it automate, or to link to the IoT, Internet of Things that want to need your creativity. See how you can make a change. So this is where the innovations come from. So how do we judge the robotic skills? We have different levels in robotic skills, but this one is classified by me. For beginner robot builder, uh, the capability is just to able to build up robots with instructions manual and able to perform actions with robots with the remote controller. So this one is just starting when you are starting to learn robotics, right? So uh, the first thing to do is to learn how to build with the instruction manual. So after building instruction manual, you will need to perform actions with the remote controller and see if you can make control of the robot with the remote controller. So without needing to touch any programming yet. When you go to intermediate robot builder, you should be able to build robot with instructions and able to modify the structure of the robot. So in coding part, you'll be able to perform simple and basic motions for robots such as move forward, backward, turn right, turn left, lift up the things, put down the things. That one is just basic one. And when you go up to advanced robot builder, you should be able to build and customize your own robot to perform specific tasks. So for example, if you build a robot that's a mobile robot movement, so if you want to lift up something, you might need to think about how to make a carrier for the robots to lift up things. And also you should be able to do programming to complete certain tasks with robot. So after you build up the arm for the robot to lift up things, you also need to program it to because when you add one arm, you should be adding at least one servo to make the arm to lift upward or downwards. So the programming also is a very important part doing this process. Then we go on to beginner robot programmer. This one is more on programming. So understand the applications of different sensor and servo motors and able to build with robot to complete certain tasks. So this one is more on you are building robots, but not just limited to servo motor. You also need to understand the sensors, and you also should be able to program the robot to collect data from environment through sensors. So for example, ultrasonic sensor. Ultrasonic sensor is a components, sensors that can sense distance, that can measure distance through sound wave, ultrasonic wave. So you can get the distance between the robots and the obstacle. So this is how we get the things uh, uh, to get the data from the environment and transmit into our laptop or into the brain of the robot. So the robot knows that what is the current status. If without sensor, the robot won't know that there's an obstacle in front. So different sensor also apply in this situation. So for example, if you put IR sensor, also sensing distance, that can serve the similar purpose, but different applications, you might need to use different sensors. So this one is also a core concept that you need to understand in a beginner robot programmer. Then when you go up to intermediate robot programmer, when you see that a lot of basic robotics kits is more on they already built up all the things like the cable easily to plug in and plug out. So if you are in intermediate level, you should be able to do wiring for sensor and servo motors for customized robot. So for example, Arduino, you should be doing your own wiring. So you need to understand what is the power supply and what is the cable for the signal. And you should be able to perform programs with variables, looping functions, at least with more effective algorithm. So this one is more on data control and also database things. So to make better control of your robots and also make the code more clean. Because in the beginner process, we normally don't care about how clean our coding is. We just need to make sure the coding can perform the task. But in intermediate robot programmer, you should be able to shorten the code, make it more simple. So this one is for the future. If you want to add some functions to robots, it's easier to customize. It's easier to upgrade. So that's why we need to have a more effective algorithm, not just for the task and also for future improvement. And when going up to advanced robots programmer, uh, you should be able to program and set up user interface for operator to do high-level programming such as PID control to reduce the latency and improve accuracy during data collections and remote control. So in this level, just now the level is more on like I set up a robots for the user to use, to just play and use on it. But this level, advanced robots programmer, you should be able to set up a user interface for the user to customize their own movement. So, and not just that, not only that, we also need to take care about the latency, because when we're doing the signal transmissions, right, sometimes it will take like 0.05 second or 0.1 second to send the data between time. So that's why we need to take care about latency to make sure it's more accurate, because we are using normally we are using internet connections or network connections that is called wireless control. So we need to know that if even 1 millisecond of latency will cause a different output, different outcome. And also in this stage, you should be able to program a robot for safety precaution. So for example, how do you, if you are building up a robotic arm, how do you make sure that it won't overturn to damage your servo motor? So that's also one of the skills in the advanced robot programmer. So here, because in robotics we have 4 different components, so I already classified it to 4 quadrants of skills. So we call it STEM engineering. The first one is the design and prototyping. It's more about designing. So if you're using EV3, you can design the robot structure by using Studio 2.0 or by using Lego Digital Designer. That one is to design your own Lego robots. Okay, but in real world, because in real world we are not going to use the brick. We are going to sometimes we are going to use metal, sometimes we are going to use 3D printed things. So design product is more on designing with the 3D printing things, also fabrication. So this one we each of the quadrant we make it to 4 levels. So design prototyping is more on Tinkercad. And then we go on to the Fusion 360. Fusion 360 is more on industrial fabrications, designing, and prototyping. So this one is more on designing, this quadrant. And the second quadrant, we call it mechanical. So mechanical is to more on building, assembly, and also figure out how to adjust the bricks or how to adjust the mechanism structures in your process. So these are more on building. And the third one is more control system. Control system is something like I want to control a robot, so I need to write a program. So this one is this part is more on programming side, and the previous side is more on design and mechanical structure. So control system is more on controlling your robots, how you move. So when we talk about robot programming, mostly is done with the control system. So the last one is called software. So software is more on doing the software applications. So this one you can go to software engineering. This one also you can make apps. You can make connections between robots and the server, and make the server connections to your laptop. So you can connect your laptop or your mobile to the robots to do remote control in a very far distance. So this also will set up your user interface, and also this will do data science to do AI, artificial intelligence. So if you learn robotics from young, you can choose different future career path. It's not just about learning for fun and learning to share out your creativity skills, problem solving skills, troubleshooting skills, as well as logical thinking skills. If you pursue for your career path, you also can go for, if you are doing design, you can become design engineer if you want to focus on design. And if you are more practical, hands-on things and more of problem solving in the mechanical structures, you can become mechanical engineer. So this one is second quadrant. And the third quadrant is more about control systems. So for example, robotic arms, you want to perform the robot control, or you want to perform AGV, auto guided vehicle control, you want to program PLC, that one is more on robotics programmer. We can call robot programmer. And if you're more on software, you want to build user interface, you want to build apps, you want to build database, you want to become data analysis, you want to do AI, artificial intelligence, you can do software programmer. So, and then we talk about the future of the robotics and also what are different levels. So the questions will be asked is, how can kids start learning? If my kids is with zero basics, how do we start learning? Okay, so here I can show one example. This one is started with Scratch in 2003 or 2008. Okay, these are the high level block-based visual programming language. If you just started your journey and you have zero basic, it's better to start with the visual blocks one. So this one we call visual blocks programming language. This is suitable for kids from 7 years old and above, which is very user friendly for zero basic learners and also easier to understand instead of typing. So the first one, this one is the make code, which is the microbit using make code like this, and this one is Lego EV3. As the third one is a Scratch. Scratch is for game development, and the last one is for Minecraft code connection. Yep. And if for preschool kids, because if you are doing the visual blocks, you still will encounter a lot of numbers over here. And for preschool kids, because we want to start it with more visual and less number input block programming, we can start with Scratch Junior or VDO 2.0 programming. And I think now a lot of China manufacturer for the robotics education kits, they are using more about this one. So easier. So for example, if you want to turn the motor like 1 second, you just put one. So without any decimal place like 1.2, it's very confusing for the kids that is haven't have a good foundations in mathematics. Okay, so what about after this? After the visual blocks, you want to pursue more advanced level, more professional levels. I recommend you to go for Python or Lua script or C# programming or JavaScript or C++ programming. This one is more on you can do it for industrial purpose, and these are the text-based programming language. So starting uh, for the Scratch Junior visual block based, it's like looking at the picture, reading the picture. Okay, like reading comics. But in here, you need to write essay. This one is more an essay. It's all text. So that's why for zero basic, if you don't want to kill your interest, it's better to start with the visual block base first, understand the concept first, then only you go for the higher level. Then it will keep your interest on. So how to choose a suitable programming language? There's no right and wrong in choosing a programming language. It just depends on the objective you want to achieve. So for example, if you are zero basic starter and if you if you enjoy text text-based programming, even if you are zero basic, then you can go for zero base. You can go for text-based programming language. But if you want to understand the concept first, because you don't know why writing few lines can make the robots perform something, so it's better to go for a visual concept first. Then after that, if you understand this, then you can try on this one, because the text-based programming language is more for industrial purpose and it's highly customized. So you can customize a lot of things. As you can see that a lot of software, they will have their software development kit. So these software development kits, it's for the developer. Developer is called a program developer. They can use the SDK software development kit to customize based on their program. Okay, so we got some limitation in the visual block because visual blocks are really customized for education purpose. So let's introduce our microbit robotics program. So we do have programs for micro beginner program. It's for 12 lessons. So it's for 7 to 12 years old to explore robotics, microbit robotics basic programming and making. And we do have intermediate program that's for 34 lessons, which is for 13 to 15 years old for higher level of microbit robotics, including sensor and servo programming and building. So these are our class. So later I'll share about our case study. And we do have more advanced programs like Arduino beginner to advanced robotics program. This one is more on text-based and also a lot of wiring you need to do yourself. This one is 36 lessons. This is suitable for 15 to 18 years old students. More on hands-on with Arduino using sensor and servo for robot building and programming. And we also have customized robotics program suitable for college and university level, especially engineering or computer science faculty. The purpose of the program is to link the fundamental of robotics to real-life applications and simulation in practical way. And this one is a recently done robotics book, not robotics bootcamp, it's a leadership bootcamp, which includes our robotics element inside. Okay, so this one is also highly customized for the bootcamp. This is suitable for participants who want to explore on new technology and learn some programming skills through robotics. Okay, so this is our teaching method. Our teaching methods is on content delivery. First is the content delivery, means we deliver the concept first concept. And the second one is challenge. They are using this concept to apply it on the challenge emissions. Challenge emissions is something like a task I give, like I want the robots to move into some place. So you need to program it with the program that I teach in the first session. And then after that, after every 12 lessons, we have a final project and assessment. So final projects will give a task like I want to make a, so let's say I take a case study. My car, okay, my car broken down. So instead of using that, instead of using the manual jack, how can I make another jack that can help myself to lift up the car to change the tire? So that's one of the tasks. So you must make something. So with the microbit, if you're using microbit, of course we are going to use a microbit. If you're using Lego, then you need to use a Lego to build the things. Okay, and then including the what's that, programming. Okay, and after that, we'll give a rewards to them. Right? The rewards sometimes will be snacks, sometimes will be reward with the robotics kits, the miniature robotic kits, and we also give certificates for them. Okay, case studies. Finlay International Secondary School, we customize and provide robotics and programming training for students in KLISS as their compulsory subject. So this program is highly customized, and the purpose is to bring the students from zero basic to intermediate to advance in 3 years program. So in February 2023, they just completed their project related to the simulation of real-life automations using microbit kits. So you can see this one is the color sorter, customized by the students. So this one is without instruction manual. They customize themselves and they do the program themselves to sort the color coming out from the top, coming to the top, and then they will sort it with red, blue, and green. Now these are students in the things. And we also completed the 12 sessions microbit beginner programs in My Cosmic Montessori Puchong for each range from 10 to 13 years old students in last year. So the title of the final lecture also relate to real-life automations. The students had completed the project successfully and made the automations out of my microbit beginner kit. So these are the projects done by them. The traffic light. Of course, in the project they can use the cardboard to like add on to their decorations. So this one is the safety door or auto safety door, and we also have a color sorter. It's not inside here. Okay, and the latest workshops we have done with University of Nottingham is in November last year also. We used Lego Inventory Robotics to train the students to build automated machines. So this one is with the theme of algae culture, which is to simulate the plant of the algae plant machine and simulate the motion also. We have done 3 workshops and 1 final presentations. They also done their final projects and complete the last semester. Okay, so why people ask me why should kids learn robotics from young? So my answer is now you can see that we have ChatGPT, right? ChatGPT can make a lot of jobs redundant. So for example, copywriting, you can just like type something, ask the ChatGPT. ChatGPT is what is ChatGPT? ChatGPT is AI, artificial intelligence, made with OpenAI. The purpose of this is they can answer your questions and the AI can help you do a lot of things. So for example, copywriting. So back in the days when we had to do Facebook marketing, when we do Facebook posting, we will do ourselves. We will keep every day we'll write copywriting, okay, to like how to give our own message to our audience. But now we don't need so much of workload in writing the copywriting. We can just ask ChatGPT, and then we can also ask ChatGPT to revamp it to the layman versions of the conversation, like more on like conversation between human and human. So to make our copywriting more like human being written one. So which is, we can see that AI is very powerful. And sometimes because we are also developing some apps ourselves, some games ourselves. Sometimes we also use your ChatGPT to help us to write some functions of the apps. So you can see that in 10 or 20 years later, the 20% to 30% jobs will be redundant, will be replaced by AI. And at the same time, also another type of jobs will rise in future also. So for example, more on technology things. So what I can see that the future now, you can see that a lot of people is developing the VR set. Myself, we bought two set of Picos, Pico XR. That one is Pico 4, and now you can see at Meta also they are using Oculus, and Apple also going to this development. They're going into the Vision Pro, which will be released in next year, March. So you can see that they are developing the virtual world, and this development is more on software development or design skill that requires in the programming. So that's why if your kids starting to touch laptop, at least touching laptop, starting to use some technology things, starting to do some coding, at least in the future, they can still make sense, make sense of the what is happening. Otherwise, if your kids didn't learn any computer skills, it's gonna be very hard for them to, I don't say survive, but it's gonna be very challenging in the future. And I will see the technology as a helping tools for us to make ourselves more productive. So that's why I will still encourage kids to learn robotics or coding skill from young. So I think that's all the sessions, all the slides I have today. And now it's the open Q&A sessions. Okay, so I'll pass the stage to. Okay, so any questions you can ask me, or share your link. Oh no, comment it. Yeah, okay. So, yeah. What are the basic equipment required to start doing robotics? Oh, that's a good question. So a lot of choices. We do have microbit, microbit, and microbit itself is more on computer science. But if you add the expansions, so we have superbit expansions, which is the Yahoo. Okay, so this is one of the kits. So this is called microbit superbit, and we also have world module. Okay, so world module is more on static one. It's not mobile version. So this one is more to learn about the sensor, the button, the components, all about sensors. And this one is the superbit is more about movement control. Okay, it's mobile, so it can do remote control, but you need two microbits to do remote control. Oh, yep. Okay. So second one is, what can young children benefit from learning robotics? Oh, young children are okay. Then I go back to this slide. Good. What can young children benefit from coding? Is this one? They can learn. They can get logical thinking skill. They can develop their problem solving skill. They can develop their troubleshooting skill. They can develop their creativity and innovative thinking. Because in robotics, you will feel a lot of challenges, because sometimes it might not be your program issue, it might be the sensor issue. So they will learn from there how to see where's the problem. Okay, where's the problem? So understand that, then so this can be applied in different places also. So for example, when you face some issue, your door locked, okay? So you will start thinking, how does the door work? Okay, seems like when you build robots, you also will feel, oh, why this one cannot work? Then you will see the structure, then you find out, oh, this one stuck. So same like what something like door happen broken already. So you will start thinking, how does it work? How do I open up it? So this one is about troubleshooting skill. And problem solving skill is more like they will start thinking. This one is more on train their thinking. So they will start thinking, why should I do this every day? It's so boring. Can I make something help me to do? So there's benefit of robotics because you can make something to help you do something, right? So this one is more on problem solving skill, and also mathematics skill also. Okay. What? Okay. Why is Lego commonly used in robotics, and are there other materials that can be used? Oh, okay. Why Lego is commonly used in robotics? Okay, when we talk about Lego bricks, right? Okay, let's say this one. This one is both microbit, right? They are also using Lego compatible bricks. Why do they need this one? Because for kids, it's very hard for them to do design because when you do a real design to do fabrications and do 3D printing, right, you need a good measurement. Otherwise, when you print out, it cannot fit. So the best way for kids, right, to build out, right, is to use the brick because they can use different type of bricks to join. If this is not good, they can just take out and then plug in a new one and to keep testing. So this is very good for them to do the shaping out. And another one is why Lego is commonly used is because now microbit, I think Lego is more well known than microbit, the Lego EV3 brick, right? Because the Lego brick, EV3 brick is they take a lot of times in R&D, and the programming is quite stable and very user friendly. And also you can remote control the things, remote upload, so it's very convenient. But the only one shortage, which is the cost is quite high. The cost to buy the Lego set is quite high. Okay, that one is our center. We invest, so we don't require the parents to buy, so they can use our one. Because one set, if I look into Saspadia, is one no, 2,000 plus, 2,000 plus, or 3,000 plus. Okay, so there are materials, other materials can be used, which is microbit. This one also for beginner. If you want higher level, is Arduino. Arduino, you also can use Arduino brick, but you need to customize yourself. And a lot of cable you need to really do yourself. Okay, that one is more on higher level. Okay, what service does SuperLogic offer? Oh, very good questions. We do have microbit beginner program, 12 lessons. This one can highly customize, so we can talk about that later. This one can customize. Let's say you want for workshops, we can customize for workshops. And we also need to understand what is the background and what is the experience your students have.
Half day workshop, full day workshop.
Half day workshop, full day workshop also got. Okay, we based on different to customize the robotics program. Okay, why is it important for people to learn about AI? Oh, that's a good question. That's a good question. Why is it important for people to learn about AI? Okay, so in AI, I want to demonstrate one thing. Okay, first thing is we need to know what is the AI first. Let's go to this. Let's try this. Open AI. So this is called ChatGPT, and now it's quite famous. When we want to do, so let's say if you are a developer, I think if you're a developer, a lot of developers also start using this one already because this one can help you write some code that you don't understand much. Okay, let me demonstrate. Okay, see my screen. Okay, so you see now I'm already inside the chat OpenAI. I can ask a question. So, can you help me write a copy writing about robotics for kids? Okay, you see, this one is AI. He'll help you to do. He'll help you to do type of things. So if we don't learn this, okay, if we don't know, because a lot of people also go into these AI things, not just about this is just one of the AI, ChatGPT. Another AI will be teachable machines, something like they can sense your face detection. That one also under AI. So you see, this one he will help you write out, so you can save your time. It can improve your productivity, and you can just proofread and also try to like modify something on it instead of just typing out yourself. I know. Sometimes people will think that it's not good to rely on this technology, but actually this one really can make you more productive, and you can use your other times, your spare time to do more creative things or do more R&D in more advanced technology. So even you can do like, can you help me to write a code for a simple website? Okay, so he will help you type out also. So
More like a tools.
more like a tools for you. So of course, this one is not exactly your answer. It's not exactly what you're looking for, but actually it's very similar already. So let's say you want to add something, you just need to copy this and then just change this one. Let's say I want to have home, I want to have about, I want to have a map, I don't want to have contact. So you can just change. So it's easier for people to refer already. So this is one of the usage of AI. So why learn AI? If you don't learn AI, let's say one day you can complete as a copywriter. If one day you can complete 3 posts, I'm not sure how the productivity works, but let's say one day you can complete four to 10 posts. People can complete at least double or triple by using this AI. Okay, another one is yep, if you are doing robots and if you are in manufacturing line, there are quite a number of our manufacturers that are using AI in camera detections, camera vision, okay, or we call computer vision, okay. So if they want to sort something, they'll use computer to detect what is the shade and which one to pick. Okay, so I hope that answer your questions. Any other questions?
I think that's all.
Okay, that's all. Then I'll pass the stage back to Fahim. Okay.
All right, thank you everybody for listening to this presentation. You can check out Super Logic. You have a website?
Yeah, we have a website.
Yeah, so the website will be
Advanced Superlogic, advanced-superlogic.com.
all right. Okay, thank you everybody for watching, and we'll see you again with the next event. We're so happy to be able to share with you, and thank you, Mr. LJ, for sharing.